Welcome to Scholastic Home Video Tutor. In this lesson, we are going to look at Trapezium rule. We are going to use AQA Mathematics Unit Pure Core 2, January 2012 examination, question number 2. So it says that 2a, use the trapezium rule with 5 ordinates or 4 stripes to find an approximate value for this integration, giving your answer to 3 significant figures. And part B, state how you could obtain a better approximation to the value of the integral using the trapezium rule. Let's see what we can do here. First, we'll take the question number 2, part A, and let's read carefully. Use the trapezium rule with 5 ordinates or 4 stripes. Basically, if you have a function, so it is like this function, it's x-axis and y-axis. In this case, the function go from 0 to 4. 0 is the first sample, 4 is the last sample, and in between there's area under this curve is the function. And then if you divide this into 4 stripes, first stripe, second stripe, third stripe, and fourth stripe, we have 5 ordinates, 1, 2, 3, 4, 5. So we need to find out the area on this curve using trapezium rule. So what we, please note that 4 stripes means 4 stripes and 5 ordinates. And the equation that we should use here is that if this is equal to I is equal to h over 2 f0 first sample plus twice of the second sample plus third sample plus fourth sample plus the last sample f4. So if you have 4 samples, 5 samples, first sample and the fifth sample, and the in between samples here. So the value h here is the distance between the width of a stripe h, and there are 0 to 4. Basically h is equal to 4 minus 0 divided by 4. 4 is the last sample value, that's the number of the last sample, 4, and minus 0, this is the range of x, but we divide it into 4 stripes, therefore you have to divide by 4. Basically you need to know that this 4 refers to the number of stripes. This is the number of stripes. In this case we have 4 stripes, and this is the max limit and this is the minimum of the limit. This is the minimum and this is the maximum of that. Basically 2 limits 0 to 4. So please note that this 4 refers to this 4, not the number of stripes. Number of stripes is down here. So when you divide 4 divided by 4 is equal to 1. So now our task is to find out these values f0 to f4. Now f0 is actually when you put the value x equal to 0 in this function. That means x equal to 0. So this will give my value I is equal to 2 to the power, when you put x equal to 0, 0, divide by 0 plus 1, to the power 0 is 1, 0 plus 1 is 1, is 1. Similarly f1, when x equal to 1, substitute in this function, I is equal to 2 to the power 1, divide by 1 plus 1 is equal to 2 over 2 is equal to 1. f2, which is equal to, when x equal to 2, I is equal to 2 to the power 2 divide by 2 plus 1 is equal to 4 over 3. Let's continue further. Okay, now still we'll need to calculate 3 more values, f3 and f4. f3 is when x equal to 3. We can calculate the value of I is equal to 2 to the power 3 over 3 plus 1, which is equal to 8 over 4, which is equal to 2. And F4, when x equal to 4, I is equal to 2 to the power 4 divided by 4 plus 1. Basically substitute here, 2 to the power 4 divided by 4 plus 1, which is equal to 16 over 5. 2 to the power 4 is 16 divided by 5. So now we found all the necessary values, and then therefore we can substitute in the equation for I is equal to, if I write it again, h by 2 within bracket f0 plus 2 times f1 plus f2 plus f3 plus f4 close bracket. So therefore h is equal to 1 divided by 2 times f0 we found is equal to 1 plus 2 times f1 we found in the previous page is equal to 1 plus f2 we found it 4 by 3 plus f4 is equal to 2. If I go back again to show that, so we got f0 1, f1 is equal to 1, f2 is equal to 4 by 3. So we substituted those values here, f1 1, f0 1, f1 1, f2 4 by 3, f3 is 2, and f close bracket plus f4 is equal to 16 over 5. So we have all the values, then it is a matter of simplification. So you can use a calculator to find out the final answer, which is equal to 6.432 if you calculate it for three significant figures. That is the answer. That is the value of, basically this shows the value of the area under this curve is from 0 to 4 is equal to 6.43. That is part A. Part B is a straightforward question. Show how you could obtain a better approximation to the value of the integral using trapezium rule. So basically what we did was we took only 4 ordinates, 5 ordinate, 4 stripes. But what will happen is that in between we assume there is flat. But in this case actually the curve can be a certain curvature. So what we can do is, instead of taking far away samples, you can make it much closer. So if you take closer ordinate or increase the number of ordinates, we can reduce the loss, the errors here. So the straightforward answer here is that increase the number of ordinates. So we have taken only 4 ordinates before, but if you took more than 4, then you can reduce the error, because the value is an approximation. To make it better, we increase the number of ordinates. It is clear that if you have a function like this, say something like this, so if you have taken only 2, you will be missing because we take it as flat here. So this area is not counted. So if you have more samples closer to each other, you will have a better approximation. Thank you.